We now want to give some brief highlights on a data analysis plan. I have seen many people who have analyzed data, or let me say correctly, attempted to analyze data without a data analysis plan. At a certain level, when you are an experienced data analyst, you may do data analysis without a written data analysis plan, but within your mind, there should be a data analysis plan. So for us who may not have reached that level, it is important to do things systematically. So you need a data analysis plan. What is a data analysis plan? Basically, you can have as many definitions as data analysts. But briefly, or basically, a data analysis plan is a stepwise, logical, coherent way of attaining results from raw data. It is a stepwise, logical, coherent journey of coursing from raw data through the rivers and valleys of the process of processing those data to the outcome, which is results, tangible results. It is like going for a tour. You need to plan. I will leave this time. I will take this and this because of this. I will take my umbrella because it may rain. I will do this. And that is what a data analysis plan is. Although when you are writing a data analysis plan, we usually start from raw data going to results. But in constructing a data analysis plan, it's the other way around. The thought process starts from the result. In other words, what do I want to show? I want to show that the exposed group has lower occurrence of the outcome than the non-exposed group. Okay, how do I show that? I have to measure the incidence in the exposed group and the incidence in the non-exposed group. Fine. Once I have the two, I need to compare them, one divided by the other to show the relative difference, or one minus the other to show the attributable difference. Okay. Now, again thinking backwards, how do I get the incidence? And here the question is it cumulative incidence? Is it incidence rate? Assuming it is cumulative, it is incidence rate, how do I get incidence rate? I need the number of new cases divided by the person time at risk. Okay, how do I get the person time? I need to get everybody from when we started seeing them before they developed the outcome or before the advent of the incident case and when the outcome occurred, and even those we observed through and the outcome did not occur at all. So for each person who developed the outcome, I need to assign them a follow-up time, which takes into account when they develop the outcome. And for those who were observed throughout and did not develop the outcome, I need to find out their person time at risk was from the beginning of the observation to when they were lost to follow-up or censored at the end of the study. Okay, so that means I have to go for every person and calculate a time of observation for them. Then what about the numerator? How do I get the incident cases? I need to find out what variables indicate that this person developed the outcome and when they developed the outcome. Then if I find out those variables, how will I work with those variables to know that this person developed the outcome? Is there a single variable or is it a combination of variables? For example, incidence of HIV may be one variable of a blood sample taken at a particular time that indicates that this person is now HIV seropositive, and the ones before indicated that the person was seronegative. Okay, is that enough? The study, the outcome may be something more strict than serological test, and want to be sure. So in this study, we may say, whoever is seropositive, we are also going to do PCR, qualitative PCR, or the quantitative PCR. And our outcome will be seropositive with a positive PCR. And if it is a combined outcome, then you now know that for me to get an outcome, I need to have results on seropositivity and results on PCR. Sometimes the outcome may be, again, a combined outcome, like a BMI. BMI involves somebody's weight in kilograms and somebody's what? Height. So if that's your outcome, then you look again back. How do I get to this outcome, BMI? I should have knowledge or data on height and also data on what? On weight. And okay, if I have data on weight, what will my weight has to be in kilograms and my height in meters. So I collected weight in pounds. That means I have to transform it from pounds to kilograms. I collected height in centimeters. I have to transform it from centimeters to meters. So you can actually now see clearly that the thought process begins from the result going backwards. And each step you have to fulfill will show you what is needed to be done onto that variable or set of variables to achieve the previous stage or the next stage. Once you have conceptualized this, and I advise you, by the way, when you are writing an analysis plan, please get a piece of paper and write these things, even going backwards from the outcome, until you reach the raw data. Then, from there, you can now write your data analysis plan going forwards. And what are the various steps we have in data analysis? First thing is know your data. That's point number one. Please know your data. Do not attempt to do data analysis on a data set that you don't understand. It is as good as trying to fly a plane when you are not trained to do so. You can always guess the results. It will be catastrophic. You may be able to place the throttle and the plane goes forward, but you will not know on what parameters to actually pull up the lift so that it can get off the ground. So know your data. And know your data is as serious as the number of times I've mentioned it. And the second thing, know what forms of data will give you results and what processes you are going to apply to the data to get the desired results as per your data analysis plan. Please note that a good pre-analysis planning results into smooth data analysis and more accurate results. But if you just get the data set and you rush into it without knowing it, you may end in big problems. So, knowing your data. What does knowing your data involve? One, if you didn't correct the data, you are not part of the study that collected the data, which is the commonest case in using secondary data. Please, when you get the variables and the data, try to get the data dictionary. Usually when we place data in public places like public enclaves or places where you can find it, we provide a data dictionary. So whoever has placed the data there will provide a data dictionary. Try to find out from the data dictionary. Read the data dictionary well to know this data set is from this study. The study was conducted here. This was the design. These were the rounds. Data were collected on this many people, that kind of thing. Now, once you know that, also try to know the variables. what variables are there in that data set. And we call that exploratory data review. Review the data before you start manipulating it. Review the data set and get acquainted with what variables are there. Of course, for the variables, you will look at mainly the variable name and what it means. You say, okay, I know that is age. I haven't checked whether age is a character or string variable or a numeric. No, but I know there is a variable for age. I know there is one for gender or sex, sex for the household head, sex for the spouse, sex for each of the children. I know there was data on income, and this income data was taken only for the household head. I know there is data on education. Education was taken on all the people who were interviewed per given household. I know there is data on contraception. Contraception was asked only the mothers and probably the girls who had reached a certain age. And so get to know the data. Explore the data. Review the data. Because remember, this is a secondary data set. You were not part of the team that collected it. So for you to use it well, you need to understand the data well, acquaint yourself with the data. Now, this is an area that is extremely important, but many people don't take seriously. Once they have the data, in their mind, they are like, I'm going to look at this and this, so I will only go specifically to those areas that contain the variables that I think I need. And they end up telling whoever placed the data in for public consumption, they end up writing to them and say, oh, there is no data on this variable, I need it. And it is there. Just because the way you thought it should be named is not how they named it. Because you were not there when they named it. So take your time, learn the data, and know your data. As you know your data, please look back to the conceptual framework. I say, from the conceptual framework, particularly the narrative part of the conceptual framework, I need the information on A, B, C, D. These are the factors I'm going to study. So as you review the data, find out, are there variables that contain information on the factors you are going to study that you indicated in your conceptual framework? And I talked about that in the previous session. As you review your data, try to find out how much of the variables or the factors you need have variables containing data on them in the data set. It will be dangerous if you're looking for 20 factors to be able to answer the question well, and you can only find data on 5 of them in that data set. In fact, it is even more dangerous if you cannot find data on the outcome itself. Even if you can find variables that provide data on 19 out of the 20 factors of interest, but if there is 0 data on the outcome, then how can you analyze data? How can you analyze those data? Because the outcome itself is not existing. All the data, all the variables from which you can construct a composite outcome are not there. So before you lose your time and energy in trying to say, let me find the summary of this variable, first of all, be sure, does this data set contain the outcome variable? Yes. Does it contain covariates that I can use to construct my composite outcome variable? Yes. Does it contain the other factors I need to study as stipulated in my conceptual framework, particularly the narrative part? Yes. Are there any other factors that I thought I would not study? I did not include them in the narrative, but they are in the schematic. Therefore, if I discover them in the data set, I could also embrace them and add them? Yes. Now, you know the data. You've done what we call a bird's eye view of the data. Now, the next step from exploratory data review is what we call exploratory data analysis. Now, here, you are going into the data set, and actually you are looking at each of the variables, your variables of interest, which you have already noted from the review that exists in the data. You know they exist in the data set from your review, and you know we have them. Now you go to the data set, and you start looking at those variables. Again, not so much in detail, but now you want to understand variable 1, V1. Is it string? Is it numeric? Is it complete? Does everybody that I'm going to analyze have data or information on this variable? Or there are some that are missing? What proportion of people or participants are missing this particular variable? What are the characteristics of those who are missing? Are they different from those that are not missing? You are now doing what we call exploratory data analysis. You want now to find out a bit in detail the composition, the nature, and the completeness of each of the variables that you are going to analyze in that data set. In fact, you could even first select them, all those variables, and cut them or pick them from the large data set, and now focus on only those and save them as a preliminary analytic data set, so that you are not disturbed by the so many thousands of other variables that are not of interest to you. So you can do, and I advise to do exploratory data analysis on a shrinked data set that contains mainly the variables that you are going to study. Find out the nature in which these variables are. Is it a count variable? Is it a percentage or a proportion variable? Where the data collected in categories, which is very disadvantageous. All the data we are collected at individual basis. For example, there are some people who go to collect age, and they collect it in a categorical form, 0 to 6 months. Any child who is 0, 1, 2, 3, 4, 5, 6 is going to be placed in that category. If that category is given a numeric number of 1, a child of 2 months, the variable will appear as 1. A child of 3 months, it appears as 1, because that's the category. Find out where data collected at individual level and recorded at individual level, or were they collected at individual level but coded in categories. That's very important, because for you may want to construct different categories, but then you have no way of knowing who has what absolute figure, because all you see are the categories. So there are many other examples I could give, but importantly, know your data, review it, and 2, conduct an exploratory data analysis. I guess I have talked a lot about that. Now, in proper analysis, try first of all look at the outcome variable. Do you have enough occurrence of the outcome variable for you to use the methods of analysis that you are going to use? Especially in this course, we use linear or logistic regression. And it could be for logistic regression, it could be the ordinary logistic regression, where the outcome is binary, or it could be the multinomial logistic regression, where the outcome has more than 2 categories, or it could be the ordinary logistic regression, where the outcome has more than 2 categories and it is ordered, it is not nominal. If the outcome has more than 2 categories and it's just nominal, we use multinomial logistic regression, the command is mlogit. If it is the outcome has more than 2 categories and they are ordered, there is an inherent order, then we use ordinal logistic regression and the command is ologit. And some cases of examples of ordered data may be pain. It may be no pain, mild pain, moderate, severe. You can see a gradient that as you move from one level to another level, either the intensity of pain decreases or the intensity of pain does what? Decreases. Okay? So that may be an ordinal variable, but of course there are other things you need to be sure that it is truly ordinal, because ordinal means that when you jump from one level to another, the change in that variable is the same as jumping from a second level to a third level. In other words, the intensity of pain from mild to moderate is the same as from moderate to severe, and the same as from no pain to mild pain. So you've got to be careful. Just because a variable appears to be ordinal does not necessarily make it fit for ordinal variable analysis. Okay, now once you know your data and you have conducted exploratory data analysis, the next thing you do is check on the outcome. Again, I've insisted it. You now know you have a good number of outcome variables. Now, if you have a major exposure, also check on the exposure to see how the exposure is distributed. Please recall that it is the nature of the outcome variable that determines the method of analysis. Please recall and note, it is the nature of the outcome variable that determines the method of analysis. If the outcome variable, for example, is categorical, the summary measures and the regression measures are different from when it is continuous. When an outcome is continuous, or the variable is continuous, we look for, let me start with the outcome. When an outcome is continuous, we summarize it using means with standard deviations, medians, and we also look at the interquartile range for every median. We look at standard deviation. So those are kind of the summary measure. There could be actual counts, there could be the mean, it could be the mean with the standard deviation or the median. And if the variable is categorical, then the way we summarize it could be the frequency, it could be the percentages. And when we start doing bivariate analysis, comparing each of these variables with the outcome, again, when the outcome is continuous, all the other variables are continuous, we use for a continuous variable for bivariate analysis, we use t-test. Or a t-test when the groups we are comparing are 2, or we use ANOVA when the groups we are comparing are more than 2. Whereas for a categorical one, we use chi-square or Pearson statistic, depending on the distribution and the number of categories. So again, it is important to not to just jump into data analysis without following, without doing your homework and getting a feel of the data and getting assembling a data analysis plan and then trying to follow it. Remember that every step you put in your data analysis plan, you should explain why. For example, I have BMI as my outcome. So at this stage, I will convert weight from pounds to kilograms. I should explain myself why. Because BMI, weight is in kilograms. I will convert height from centimeters to meters because to calculate BMI, height should be in what? In meters. So give an explanation of what you are doing. I will use a t-test because I'll be comparing this continuous variable across the categories of a binary variable. Before I do a t-test, I will do a variance ratio test. Why? Because I need to know whether the assumption of equal variances that is required by the t-test is fulfilled or violated. So you give rationale for what you are going to do. And again, that goes back to the statement of stepwise, logical, coherent. The logical part explains why you are planning to do what you are going to do. It's not just gut feeling or just, thoughts from the blue. You should be able to explain what we are going to do and why you are going to do it. That's a much detailed and very helpful data analysis plan. When it comes to regression analysis, it is the outcome variable that determines the method. If the outcome variable is continuous, we use linear regression. If it's categorical, we use logistic regression commonly. If it's a count, we use Poisson regression. If it is time to invent, we use survival analysis. And please note that there is a difference between the endpoint and the outcome of interest. Many people who do cross-sectional studies, even indeed cohort studies, there are studies where the endpoint is also the same thing as the outcome of interest. But this is not always the case. And I want to demonstrate this on the board. Sometimes the endpoint is also equal to the outcome of interest. Outcome of interest. But sometimes the endpoint is not equal to the outcome of interest. Let me give you an example. If you are doing a study to find out the incidence of viral suppression, viral load suppression, the time, once we find that this individual X at this time suppress the virus, when we just need to know which individuals suppressed and which individuals didn't. The end point is the day suppressed, then it is also the same as the outcome. What if we want to know incidence of HIV? All we need to find out, we collect blood at different times. We find out, does it contain HIV, does it not? Does it contain antibodies to HIV, does it not? So the time, once we find out that for person X now is HIV positive, this is HIV positive, the end point is also equal to the outcome of what? Interest. However, we may be interested in knowing how long it takes from start of ART to viral load suppression. So we need to have the start of the exposure. Start of our observation is going to be the date of ART start. Then we follow out this person, and then we get the date of viral load suppression. This is an endpoint. But the outcome is not viral load suppression. The outcome is the duration it takes from start of ART to viral suppression. The endpoint that helps us to calculate this outcome is data of value separation. But in and by itself is not the outcome of what? Interest. We may be interested to find out, start off a certain behavior. How long does it take when somebody engages themselves in commercial sex activities? Commercial sex activities, when they are HIV positive, to the time they get HIV infected. How long does it take? Of course, you can see we shall have a start date, and we keep taking blood from this person. Then at this time we find out that they are HIV positive. This HIV positive is the end point, but it is not the outcome of interest. The outcome of interest is how long did it take before somebody develops the end point. So the end point and the outcome of interest are not one and necessarily the same thing. It really depends on what is being studied. Okay, so how did we get here? We got here by stating that the nature of the outcome variable determines the method of analysis that you are going to use. If the outcome variable is continuous, we use linear regression. And the assumptions that you should have covered in the biostatistics 1 and 2. There are also some for logistic regression, and there are also some for +1, and there are some for time to event. And for example, the Cox proportion model has its assumptions. And so, outcome variable determines the kind of regression analysis or any analysis that you are going to do. So it is important to check the nature of the outcome variable. I think I have covered the preliminaries that are required before we get into the actual touching the keyboard to do data analysis. Now, the next session we are going to have will be on exploratory data review. Then we shall follow that with exploratory data analysis. Then there will be a session on assembling an analytic data set. Then we go through the actual analysis. And so we still have about 4 to 5 sessions that will come after here. This session ends here. Next time we begin on the practical one with a data set. Thank you.